Hi, let's solve this problem. Given u bar of z is equal to 8z minus z cube by 4 minus z the whole cube, we have to find inverse z transform for this problem. So, given u bar of z, we have written like that. Normally, we used to take z common from the numerator and we'll keep it down. Finally, we need z in the formula, so we'll bring it back. But in this problem, we are not going to do so because the denominator has repeated linear factors. If you see, okay, if you 4 minus z, it's not in formula format, so z minus 4 we'll write it. So z minus 4, I have taken the negative sign outside. Okay, this negative sign we can push it to the numerator. So z cube minus 8z by z minus 4 the whole cube. First let's write it in the formula format, because always z minus k the whole square, that is the formula format, right? So now see the denominator, it is z minus 4 the whole cube. If I split it into partial fraction, first z minus 4 will be there, second z minus 4 the whole square, third one z minus 4 the whole cube. So for the first one, we need only z in the numerator, z by z minus 4, z by z minus k. That is a formula format. So no problem here, we are done with. So now if you see z minus k the whole square here and z minus k the whole cube here, what is the corresponding formula that is related to the denominator? See this? Z transform inverse of kz by z minus k the whole square is k power n into n. Similarly, z transform of kz square plus k square z by z minus k the whole cube is equal to k power n into n square. K power n into n square. In the place of k, I have z minus 4. In the place of k, I have 4. So now how it will be? So here kz, so 4z we have written. Here kz square, 4z square plus k square z, 4 square, that is 16z. So we are fixing the numerator depending on the denominator because it has to be in formula format, and hence it's easy to solve when we apply z transform inverse. You got it? So here we are not going to take z common and push it down. Okay. So in these type of, check the denominator. If the denominator has repeated linear factors and power square and power 3 means you have to adjust the numerator accordingly. At least here in the final answer you can multiply by 4 and divide by 4 and write it here. But in this case you cannot bring it to formula format just like that. So this is your given question on the left hand side, and the right hand side a is it plus second term plus third term, whatever it is there as it is. Okay, now what we can do is we can take LCM. Okay, a z into what is the maximum term, z minus 4 the whole cube, right? Denominator LCM. So z minus 4 the whole square you will multiply. Okay, or to be in short, if the power is 3, already one z minus 4 is there, you are multiplying by z minus 4 the whole square with the numerator and denominator, and here z minus 4 with the numerator and denominator. If you do that, so denominator everywhere z minus 4 the whole cube. That is why az into z minus 4 the whole square first term plus 4bz into z minus 4 second term plus third term, and here the whole divided by z minus 4 the whole cube. It will be like this. The whole thing divided by z minus 4 the whole cube. Here also whole thing divided by z minus 4 the whole cube. This and this will get cancelled. That is why we didn't write the denominator here. Okay. So now after this step, we didn't take the z down, right, common from here. So here we can cancel z from both the sides. Extra z is there. So z cube minus 8z, if I take z common, what I'll get? I'll get z square minus 8. And right hand side, 1z if I take, z minus 4 the whole square. Here 4b z minus 4. The last one, 4z square plus 16z, I have taken z common. So 4z plus 16. Okay. Now if you substitute z as 4, this will become 0, this will become 0, and you will get c. Simplify on your own. That is, if you substitute z as 4, what you will get? 16 minus 8 is equal to 0 plus 0 plus c into 4 4 16 plus 16. Okay, oh here it is. So 8 is equal to 32c, c is equal to 8 by 32, 1 by 4. So similarly, if I substitute z as minus 4, okay, here we will be getting terms more than one variable, because z is equal to 4 is one solution. You can put z is equal to 0 also. So if I put z is equal to minus 4, I will get, this term will become 0, c will become 0. I will get an equation in terms of a and b. So this is your equation. If you put z is equal to 0, then what we will get? We will get an equation in terms of a, b and c, but okay, we know the value of c, we can substitute. So now if you see these two equations, it's a combination of a and b. Two equations, two unknowns. If you solve it, you will get a and b. Okay. So z is equal to 4, I am getting an equation in terms of a and b. Z is equal to 0, I am getting an equation in terms of a, b and c. Already I know the value of c. If I substitute, I will get an equation in terms of a and b. So solving these equation 1 and 2, we get, yes, we get b as 7 by 4 and a as 1. Try to solve these things on your own. So once you got a, b, c, just you have to substitute in the given problem. U bar of z is equal to az, that is 1z by z minus 4, plus b into 4z. Don't cancel this 4 and this 4. We need this for the formula. B into 4z by z minus 4 the whole square, b is 7 by 4, plus c is 1 by 4 into 4z square plus 16z by z minus 4 the whole cube. Okay, so please don't cancel. We want 4 in the numerator because this is the formula format, k z by z minus k the whole square. So now applying z transform inverse on both sides, we get z transform inverse of u bar of z, I will get un, and z by z minus 4 we have, so that is nothing but k power n, so 4 power n, and 7 by 4 into k power n into n, 4 power n into n, plus last term k power n into n square, that is 4 power n into n square. Looks very easy, but you may tend to do mistakes in finding the ABC simplifications or even fixing the problem itself. Let me see this. Now just try to resolve this into partial fractions. Purposefully I hope the next line is not visible. U bar of z is 4z square minus 2z by z minus 1 into z minus 2 the whole square. Just take a minute and try to resolve this into partial fractions. As I told you, it should be in the formula format, and here the first denominator is z minus 1, second denominator will be z minus 2, third denominator will be z minus 2 the whole square. So I think I should not give clue than this. This is a kind of easy problem because first one also we want only z in the numerator, second one also we want only z in the numerator, but for the third one z minus k the whole square, so we want kz, so 2z should be there in the numerator. That's it. So here even if you take z down to the other side and bring it at the final moment, that is not going to create any problem when you are finding the inverse. So you can keep z as it is in the numerator and solve it, and if you do that, so what we will do, we will take LCM, z minus 1, z minus 2, and here it is z minus 2 square, right. So z minus 1 by z minus into z minus 2 the whole square will be the common factor, z minus 1 into z minus 2 the whole square. So we will cancel. So whichever term is missing, we will multiply in the numerator and denominator. Here z minus 1 is there, square is missing, so z minus 2 square we are multiplying. Second one, z minus 2 is there, but see the denominator, z minus 1, z minus 2 square. So 1 z minus 1 and 1 z minus 2 is missing, so we are multiplying that by the numerator. And then last one, z minus 2 square is there in the denominator, which is missing, z minus 1 is missing, so we are multiplying. So eventually the idea is we are taking LCM. So if you see the denominator, z minus 1, z minus 2 the whole square. If it's there, I can take it. If it's not there, I will multiply and divide by it and then take that value constant. Now try to find, again you can take z common on both sides. Otherwise, if you don't take z and then you have to compare the coefficient to simplify and to get the answers. So always after this step, divide by z on both sides. Okay, this is very important. Yeah, now you can see. So divide by z on both sides. So what I'll get, 4z minus 2 on left hand side. Right hand side, a into z minus 2 the whole square. Expanded that. Plus b into z minus 1, z minus 2 multiplication is this. Z we have cancelled it. Plus 2c into z minus 1. Now you can find a, b and c. So after the simplification, we got a as 2, b as minus 2 and c as 3. Okay, please check by yourself. And finally, we are just substituting in the equation. So 2 into k power n, 1 power n minus 2 into, here k is 2 power n plus 3 into 2 power n into n. So you can take 2 power n constant as a common term outside, and then we can simplify it. So basically we are adjusting the numerator according to the denominator to bring it in the formula format. So from the next class onwards, we will be seeing problems in solving difference equation. So this will be a part of solving the difference equation. Let's see in the next class. Thank you.